Okay, welcome back to lectures on advanced calculus for engineers, and in this lecture we will continue indeterminate form, which was partly covered in previous lecture. So the content for this lecture will be we have not discussed, for instance, the 0 into infinity form or infinity minus infinity, and this another group where we have these exponents, so 0 power 0, infinity power 0 and 1 power infinity. So all these indeterminate form will be covered in this lecture. What we have already seen in the previous lecture, these two types of indeterminate forms were discussed and some examples were also done. And here also in that lecture we have learned that this L'Hopital rule is very useful for computing the limits, and that rule says that this limit is equal to the limit of the ratio of f prime over g prime. Well, and this we can continue if in case we have again the situation of 0 by 0 or infinity by infinity, we can move to the higher order derivatives, the ratio of the higher order derivatives. Now we will discuss the other types of indeterminate forms. So for instance, we have 0 into infinity. So in this case, suppose this fx goes to 0 and gx goes to infinity as x goes to a, then the question is that what will be the limit fx into gx as x goes to a, because this is also an indeterminate form. We don't know what is that number 0 into infinity. But in this case, this is very simple to handle and we can get back to our 0 by 0 or infinity by infinity form easily. If for instance we write fx into gx in this form, fx divided by 1 over gx, then what will be the situation here? This fx goes to 0 and this gx was going to infinity, so this is also going to 0. So we have again the case like 0 by 0 form, which we know how to handle using this L'Hopital rule, for instance. Or we can also rewrite like gx divided by 1 over fx. So here the gx is going to infinity and 1 over fx will also go to infinity. So we can convert to one of these situations, either this fx over 1 over gx or gx over 1 over fx, and in both the cases we can handle the situation using the L'Hopital rule. Well, so we will see the example. For instance, here we have x into sine 2 over x. So x goes to infinity, so here this part is going towards infinity, and we have sine 2 over x and x goes to infinity, so this goes to 0. So we have 0 into infinity form, and we will handle exactly what we have learned just before. So we will rewrite this sine 2 over x and divided by 1 over x. We have not written it like x divided by 1 over sine 2 over x, because here the getting the derivative of then the denominator term will be difficult. So we have to think about whether we convert to 0 by 0 form or we convert to infinity by infinity form. So here we have convert to 0 by 0 form, and in that case we will now apply the L'Hopital rule. So here sine will become cos 2 over x, and the derivative of this cos of 2 over x will be minus 2 over x square, and then we have 1 over x. So the derivative will be minus 1 over x square. So this term gets cancelled with this term, and we have simply cos 2 over x, and x goes to infinity. So cos the argument goes to 0. So cos 0 is 1. So here we have the value 2, because this 2 was there. So 2 into 1. So we have the limit here 2 in this case using L'Hopital rule, just by rewriting the term to make it form 0 by 0 or infinity by infinity. Well, so although this L'Hopital rule can be applied to either 0 by 0 form or infinity by infinity form, but as we have already observed that one may be better in a particular case. Like in earlier case, it was better to have 0 by 0, not the infinity by infinity form. So we can always change between these form just by rewriting, like fx, you can rewrite 1 over f there and 1 over g. So, we can always change this. So, again one more example here. So, for instance, we have this x power n and ln x. So, this x power n is going to 0 and this ln x is going to minus infinity. So, we have 0 into infinity form, and then we have to think again here whether it is better to have 0 by 0 form or it is better to have infinity by infinity form. So, we consider here the ln x in the numerator and then 1 over x power n in the denominator, because the same reason as earlier, here it is easy to differentiate the ln x. So, we have simply 1 over x, but if we would have written like x power n and then 1 over ln x, then this is complicated unnecessarily. So, it will not help us. So, better to write in this case this infinity by infinity form. Earlier it was better to have the 0 by 0 form. Well, now it is infinity by infinity form and we can apply the L'Hopital rule. So, the L'Hopital rule means the derivative here 1 over x and the derivative here which will be minus n over x power n plus 1. And this when x approaches to 0, because this x will go to x n divided by this n and x goes to 0. So, this will go to 0. So, we have this limit as 0. Fine. Now, we move to the other indeterminate form, which is infinity minus infinity. And what is interesting actually, that this form also we can rewrite the given terms in to make it the form 0 by 0 or infinity by infinity. So, here the question is that fx goes to infinity and gx goes to infinity as x goes to a, then this fx minus gx as x goes to a is indeterminate, because you have infinity minus infinity situation which is not meaningful, where we do not know what is the value of this infinity minus infinity. So, in this case we rewrite this fx minus gx as fx minus gx, we divided by fx into gx and multiplied by fx into gx. Remember that fx and gx both are going to infinity. So, here this fx into gx will go to infinity, this is also going to infinity, and what we now rewrite this one here fx over fx gx, that means 1 over gx, the second term will be 1 over fx, and then this we can write 1 over fx gx. And now we see what is happening here. So, the gx is going to infinity. So, this is 0 minus 0. So, that is 0, and here 1 over this fx into gx is going to infinity. So, 1 over infinity, this is also going to 0. So, we have the numerator going to 0, also the denominator is going to 0, and this is a 0 by 0 form. So, we can always this infinity by infinity minus infinity type of indeterminate form we can handle just converting into 0 by 0 or infinity by infinity form. We will see with the help of example. So, here we have, for instance, limit x goes to infinity 1 over x square minus 1 over sine square x. So, in this case what is happening here, the first one is going to infinity, the second is also going to infinity. So, we have infinity minus infinity form, and if we rewrite this 1 over x square minus 1 over x square, just take this denominator common. So, we have x square sine square x, then the numerator will be here sine square x and then minus x square there. So, we have the common denominator sine square x minus x square, and now if x goes to 0, we have the numerator which is going to 0 and also the denominator is going to 0. So, we have basically 0 by 0 form where we can apply L'Hopital rule again. So, let us do that. So, here this is 0 by 0 form. So, we apply the L'Hopital rule. So, sine square x minus x square. So, you will have we have just rewritten for simplicity. So, here the sine square x, because x square is anyway there. So, we multiplied by x square and then here also we have multiplied by x square. So, this becomes x4, and this is, as we will see here, x square over sine square x. This limit is very easy to handle. So in a minute we'll come to this part. Then first let's compute this sin square x minus x square over x4 first. So this is 0 by 0 again, so you have the numerator 0 and denominator is also 0. So we apply the L'Hopital rule. So sin square x will become 2 sin x cos x, then here x square will be minus 2x, the derivative of x square, and then this x4 will be 4 into x cube. So now we check, so here 0 minus 0 over 0, so again we have 0 by 0 form, so we need to apply this L'Hopital rule again, and this is 2 sin x cos x, this is basically sin 2x, so we can apply that. So 2 cos 2x, the derivative of this term, minus this 2x means 2, and then 4x cube will be again the derivative will be 12x square. So what we observe that here when x goes to 0, this is again 2 minus 2, so the numerator is getting towards 0 and also denominator is going to 0. So we have again 0 divided by 0 form, and then we can apply this or basically what we are getting now. So 2 if we take common, we have cos 2x minus 1. So cos 2x minus 1 is sin square x, and then there will be, so the cos 2x and minus 1 if we take that 2 common. So this will be cos 2x means 1 minus 2 sin square x and minus 1. So this one gets cancelled, we have 4 sin square x and it was 12 there, therefore we are getting here a 3, and then with minus sin square x over x square. So we have this, there was x square over sin square x, here we have sin square over x square term. Well, so now let's handle this one first, x square over sin square x. So we have 0 divided by 0 form. So in this case we can apply the L'Hopital rule again. So we have 2x over 2 sin x cos x, and again we have 0 by 0 form. So we apply L'Hopital rule again, so we will get 2 there, and here sin 2x which will be 2 cos 2x. And now if we apply this L'Hopital rule further, we have 2 over 2 into 1, so this is 1. So this limit is 1, and similarly this limit which we got here sin square x over x square, that can be also that is also 0 by 0 form, and we can apply L'Hopital rule, and there also we will see that limit is 1. So finally what we are getting here, this is 1 by minus 1 by 3, so this is 1 and this is approaching to minus 1 by 3, so minus 1 by 3 into 1, so we have that limit minus 1 by 3 for this case. Another example we have here for this limit x goes to infinity, and we have x plus 1 over ln 1 minus 1 over x. So in this case we observe that when x goes to infinity, so this is going to infinity, fine, and here 1 over 1 minus ln x. So this 1 minus 1 over x for x large, this is less than 1, so this ln will take negative values, and when x goes to infinity, that means this is going to 0, so ln 1 will become 0, but it is coming from the negative side to 0. So the value of this 1 over ln 1 minus 1 over x when limit x goes to infinity, this will not be so this ln 1 0, so this will not be like plus infinity, rather this will be minus infinity, because ln 1 minus 1 over x, these values are always negative, and when ln this x going to infinity, this will just approach to 0, but with the negative, from the negative direction. So this number here will go to minus infinity, so we have plus infinity and then we have minus infinity. This is not plus infinity is infinity, so we have to be careful here that this ln 1 minus 1 over x is approaching to 0, but from the negative side, and therefore 1 over this 0 from the negative axis will become plus infinity or minus infinity. So, we have plus infinity minus infinity case. So, this form is clear with this observation that this is going to minus infinity. So, we have the situation infinity minus infinity in this case, and then we rewrite this. So, x goes to infinity, we have x and then 1 over ln 1 minus x. So, this we will rewrite now. So, x into ln 1 minus 1 over x plus this 1 divided by this 1, and now see the situation. So, x goes to infinity, this is going to infinity, this is 0. So, plus 1 and then this is going to ln 1, this is going to 0. So, we have that 0 divided by 0 form. One has to check this one, that x goes to infinity and this ln 1 this is going to 0. So, this one can check separately, and we will see that this is going to minus 1. So, at the end we are getting 0 by 0 form. Well, so now we can apply this L'Hopital rule. So, x goes to infinity and this will be the derivative of this. So, we will get ln 1 over 1 minus x, and in the second case x will remain as it is. We will take the derivative of this, which is given here, and same with the derivative of this we will get. So, this is ln x minus 1 divided by x. So, we take the derivative, it is 1 over this. So, it will be x over x minus 1, which is term given here, and the derivative of minus 1 over x will be 1 over x square. So, therefore, the derivative is given here, x over x minus 1 into 1 over x square. Well, and then we see that this is 0 by 0 form by taking this limit x goes to infinity. So, we need to apply this L'Hopital rule again, and after this application of the L'Hopital rule, we observe that this is the limit is getting to half. So, here we have applied this L'Hopital rule several times, but the question here was, once you have this infinity minus infinity form, that can be converted to like either infinity by infinity or 0 by 0 form, and then we can handle with the usual L'Hopital rule. Fine. So, now we consider the limit here, limit x goes to infinity, e power x plus e power minus x and minus e power x. So, another example where we have e power infinity and e power minus infinity will be 0. So, e minus e power minus infinity. So, you have the case again infinity minus infinity. So, in this case also we have to handle this by converting this expression into 0 by 0 or infinity by infinity form. So, here it looks simpler because e power x and e power x is common in both. So, what we will do then, e power x we will take common and put into the denominator e power minus x, and now we see the situation that this is 0 and this is also getting to 0. So, we have 0 by 0 form where we can apply the L'Hopital rule. So, in this 0 by 0 form, so we differentiate this. So, e power minus x and the derivative of e power minus x will be minus e power minus x, here also e power minus x, and we have the derivative as e power minus x. So, here this gets cancelled and we have e power minus x as x goes to infinity, and then we have this e power 0 which is 1. So, here the limit is 1. Well, so we move to this set of indeterminate forms. How to handle this? There is a simple trick which can be used and we can evaluate all these limits. So, consider a situation that x goes to a and we have fx power gx. Suppose fx and gx have the following properties to cover all these situations. So, fx goes to 0, gx also goes to 0, x goes to 0, meaning this 0 power 0 situation we are getting, or we are getting infinity power 0 situation, or fx goes to 1, we are getting the third situation, x goes to infinity. So, in all these cases what we will do, we will consider this y is equal to fx power this gx and then we take the logarithm. So ln yx this side, and there will be gx ln fx. So that is the trick I was talking about, and once you take the logarithmic there, this will become, so the gx here is going to 0 or infinity. So first two cases gx was going to 0 and ln was either going to 0 or infinity. So in both the cases infinity, so you have 0 into infinity form, and in the third case gx was going to infinity and fx is going to 1. So again here also we have 0 into infinity case. So in all these three cases, this once we take the ln, the logarithmic both the sides, we have the situation 0 into infinity, and we know how to handle the situation 0 into infinity by converting into 0 by 0 or infinity by infinity form. Well, and then once we have this situation, so we take the limit, and in the ln here we have the continuity assumption. So this limit will go to the yx. So we have the limit of yx which we need to evaluate, and the right hand side this limit we can evaluate because here we are getting 0 into infinity form, and at the end once we get this limit we can take the limit of this yx by taking the exponential both the sides. So we will get e power l. So the evaluation of this limit is the main task, and then e power l will be the desired limit in these cases. So we go through quickly a few examples of this nature. So for instance, we have here x goes to 0 plus and we have x power x. So we have the situation 0 power 0 here. We take y is equal to x power x and take the logarithm both the side. So ln y is equal to x ln x, and then the limit here x goes to 0 plus ln y is equal to x ln x. And here now just we see here, so 0 and ln 0 is going minus infinity. So we have the situation 0 into infinity, which we know how to handle this. So this is ln x over 1 over x, we write this, and then we have infinity by infinity form which we can handle using the L'Hopital rule. So if we apply the L'Hopital rule there, 1 over x and then here minus 1 over x square, and x will go to the numerator then, and x goes to 0. So we have this limit 0, and then getting the limit for the y, it will be e power this limit 0, and we have that 1. So the desired limit for this x power x when x goes to 0 is 1. Another example, we consider cos x power 1 over x where x goes to 0. So when x goes to 0, this cos x will go to 1 and 1 over x will go to infinity. So we have the situation here 1 power infinity type indeterminate form, but we will be handling taking this logarithm. So we have y is equal to cos x 1 over x, we take the logarithm both the sides. So we have ln y, here we have then 1 over x into ln cos x, and we see that when we take the limit x goes to 0, so this ln 1, so this is 0 by 0 form. So we apply the L'Hopital rule. So here ln cos x will be 1 over cos x and minus sin x, and the derivative of x is 1. So we have used here the L'Hopital rule, and then this when x goes to 0, so sin 0 over cos 0 1. So this is just 0, and then taking the exponential both the sides, we will see that e power 0, again the limit is here 1 in this case. So here we have the last example. So consider this limit x goes to 0 plus 1 over sin x 1 over ln x, and when this x goes to 0, so sin 0 is 0, so this is going to infinity, and then here also infinity, but 1 over infinity it is going to 0. So we have the situation infinity power 0, and we will handle again by taking the logarithm. So we have here the y, the given expression, that take the logarithm. So we have 1 over ln x and ln of 1 over sin x, and we take the limit both the sides. So taking the limit here, we have ln of 0, so that is also infinity by ln 0 infinity. So infinity by infinity form, and we apply the L'Hopital rule. So we have applied the L'Hopital rule here. So this ln sin x. So, we have this sin x and this 1 over sin x is minus 1 over cos sin square x and sin x is cos x. So, the derivative of this ln sin x is here in the numerator, and then in the denominator we have basically ln x. So, we have considered this limit as again limit 0 plus, and then in the numerator we have 1 over sin x, and here we have the ln x, right. So, this is infinity by infinity form, and therefore, we applied here the L'Hopital rule. So, for ln x the derivative is 1 over x, and now when x goes to 0 we have to see. So, here we have sin 0. So, this is anyway sin x. So, cos x over sin x, and this is x. So, cos x, and then we have again sin x there. So, again we are getting 0 by 0 form, and we have to apply L'Hopital rule again, because this is 0 and this is also 0. So, we apply that L'Hopital rule again, and we will get this limit as 1. So, what we have seen that we can handle all these forms, whether infinity power 0, infinity minus infinity, by somehow converting to the 0 by 0 or infinity by infinity form. So, in this case, so at the end we should not forget to take the exponential there. So, e power minus 1. So, this is 1 over e, the answer there. So, to conclude this, so we have handled several indeterminate form. The most fundamental was 0 by 0 or infinity by infinity, where with the help of L'Hopital rule we can compute those limits, and all others. So, this was very easy to, this can be converted into 0 by 0 or infinity by infinity form. Infinity minus infinity also we have seen that by some rearrangement, by rewriting the terms, we can easily get into 0 by 0 or infinity by infinity form, and these three group, by taking the logarithm we can again convert into 0 by 0 or infinity by infinity form. Fine. So, this L'Hopital rule was the key for this evaluation of these limits or handling these indeterminate form, and with this, these are the references which are used for preparing this lecture, and I thank you for your attention. Thank you so much.